Section 9-4, Part 3. This is continued from the previous podcast. The effects on parallel lines. Parallel lines are taken to parallel lines. We have trapezoid ABCD, and trapezoid EFGH. We know they are congruent. We just got through talking about the corresponding sides of this trapezoid are congruent to the corresponding sides of this trapezoid and angles as well. But also parallel lines are taken to parallel lines. Here we have AB is parallel to DC. Therefore, we also know that EF is parallel to GH. All right, so parallel lines are taken to parallel lines. Next, let's look at this example. Determining if figures are congruent. Is triangle JAR congruent to triangle LID? That's our question. Are these two triangles congruent? So think about it. Here's a triangle here. Is this triangle congruent to this one? Now, to be congruent, it means the corresponding sides of one triangle are congruent to the corresponding sides of the other, and all of the corresponding angles are congruent to the corresponding angles of the other. Okay? So, what we first want to do is if we can determine if there has been a mapping, is there a translation that can be performed from this triangle to this one? Can we reflect it? What has happened, or can we prove that we can go from this triangle either by a slide and then a reflection, or by two slides or a rotation? Can we find that mapping to go from one triangle to the other? If we can, then yes, these two triangles are congruent, okay? So I want us to look at the first example here. Let's look at this one. Let's look what happened. All right, here was the original JAR, okay? Now let's think about it. We're trying to get it to this position. Now, if we move every point of the original triangle to the right 4 and down 1. Let's see what happens. If we move every point, 1, 2, 3, 4, and down 1. Okay? So what we're doing is we're trying to line up and get it close as we can to this ending triangle. So we translated to the right this triangle, 4 units to the right, 1, 2, 3, 4, and down 1, okay? Now, with that happening, next we can reflect this triangle over the x-axis. If I reflect this triangle over the x-axis, let me do that again. If I can take that triangle and reflect it over the x-axis, it fits perfectly onto our ending triangle. Now, I'm going to put a B on this triangle, and I'm going to put an E on this triangle. This is the beginning triangle, and we're trying to get to the ending triangle by using translations, reflections, okay? Whatever we can use to get it to the ending triangle. So, let's go over that again. Here I am at the beginning triangle. I'm trying to move it as close as I can so that I can reflect it over and find the ending triangle. So if I move it 4 units to the right, 1, 2, 3, 4, and down 1, it fits perfectly there. Then if I take that triangle and reflect it over, now remember we talked about if a point is lying on the line of reflection like D is, when I flip that triangle over, D is still going to be lying on the point of, or the line of reflection. The line of reflection is the x-axis. I took this triangle and reflected it over the x-axis and found this triangle, okay? So, we had a translation of 4 units to the right and 1 unit down, followed by a reflection across the x-axis. Therefore, this mapped triangle, the original triangle JAR, it mapped it to triangle LID. Okay? Now, keep in mind, let's go back. Here I have this triangle, and I'm going to label these letters. A, this is A, this is R, and this is J. Okay? So ARJ. Now, when I move it to the right 4, 1, 2, 3, 4, and down 1, here's the letters that I have. Okay? Now, as I flip this over, R is right here from the original triangle. Now let's look at it this way. As I flip this one over, as I flip it over here, okay, as I flip R over, this one is A, and this one is my J. So let's look at that again. So here I translated it 4 units to the right. 1, 2, 3, 4. There I have it here. Okay. Now as I take that triangle and flip it over, this is what I get. Okay. So who does R correspond with? D. Notice if R is the third letter, who else needs to be the third letter? D. Now, who does A correspond with? I. That's an I. So A corresponds with I. If A is in the middle of my congruent statement, I needs to be in the middle of the other triangle's congruence statement, okay? And then who does J correspond to? J corresponds to L. So if J is in front, L must go in front. So you got to make sure that you pair up the correct original angles from this the beginning triangle with the ending triangle's angles, okay? So again, here was what I got when I when I translated it here. I moved it over, but then when I reflect it over, that's what I get. So in my congruent statement, R must go with D, and mine does. A must go with I. A is in the middle, my I is in the middle. J must go with L. J is the beginning, L is the middle. L is the beginning. J is the beginning, L is the beginning. Now, you can have different congruent statements that still mean the same. Like I could have triangle ARJ, and who would it be congruent to? Okay, who does A correspond to? A corresponds to I. Well, if I start with A, I has to go first. Who does R correspond to? D. So if R is in the middle, D's got to go in the middle. If I end with J, J corresponds to L, therefore I have to end with L. So that's one congruent statement. And then I could just use the original ones that I started with. JAR is congruent to triangle LID. You can have different congruent statements and they still mean the same thing. Because look, A corresponds to I in this congruent statement. A also corresponds to I in this congruent statement. R goes with D in this one. R goes with D in this one. They're at the back. J goes with L at the back. J goes with L at the front here. As long as your corresponding parts of the congruent triangles are paired up, then your congruent statement is correct.